Hello, good afternoon. I'm very pleased to be here. My name is Javier, and today I'm going to talk about how to deploy your Flask app. Let's say you've built a Flask application, and now your next step is to deploy it to production. And we are going to be biased a bit into containers and Kubernetes in the way we can deploy your application. And what we really want is to have really a production-ready deployment, not just copy some files to a production service. The tooling we are going to use does just work for, it works for other frameworks. It's not just related to Flask, so you can use it with Flask, Django, or FastAPI. Not sure about Django Ninja because I've never tried it, but I will do it. So let's go for it. First of all, introduce a bit the agenda that we are going to tackle in this talk. We will make a very quick introduction to the topic. Then we will have a small demo Flask application, so we can proceed with deployment options. Then first we will go to deploy using Helm charts. Probably you've heard about Helm charts. They are like a kind of packaging system for Kubernetes that it's based on templates. Then we will go through Fly.io as a platform as a service. We will go after that through Juju. Juju is an orchestrator for software operators. It's built by Canonical. Canonical is the company I work for. And if you don't know Canonical, probably you know some of our products like Ubuntu or NetPlan or Cloudinit, LXC containers, and things like that. And finally, we will make a conclusion of the things that we've seen over the talk. So let's introduce the topic. You've created an amazing Flask application that you want to expose to the world. You have a really, let's say, good API, and you want to make it ready to run in productions on K8s, Kubernetes, or in a kind of containerized environment. Flask.io or other PaaS are a bit different because some of them are not based on containers, and that's the case of Fly.io. And what are the options that we are going to tackle? Helm charts as the packaging system for Kubernetes. That it's very close to Kubernetes. There are other options like Customize that will also help you, or you can just go directly with Kubernetes and write the plain manifests. The second option is platforms as a service. Fly.io is just one example, but you have Heroku, you have Google App Engine. Heroku is especially interesting in this field as they were the proposal of the 12-factor methodology. And the third one is Juju Ops tooling as an orchestrator of software operators. That is operators that handle applications. Let's say like real operators that make the applications work correctly. They are quite famous now. The operators in the Kubernetes world related especially to stateful applications. What we are doing here can be done in K8s in your premises or in cloud providers. And this is our Flask application. It's a very simple one. We don't want to tackle the complexities of Flask applications, and what we really want to concentrate is in the deployment process. And as you can see, it's just a root endpoint that replaces Hello World. Probably you don't want a full Kubernetes cluster just for this application and a few users. So here we go, and the first thing we probably want to do is to create an OCI image for this application. If you search in Google, you will see something very similar to this, which works. As you see, it uses a base image from Python, and it will copy the requirements, install the packages, and copy everything, and then run your Flask application. It has a few problems. The first one is that you are copying everything to the Docker image, so it can be quite big. It can be even problematic to copy local secrets or other things. And the second problem is that you are using Flask in developer mode, which is not recommended for a production deployment. Both things can be fixed. You can do it. The copying is easier. The other one is a bit more tricky. You will need a WSGI server and maybe some instrumentation or other things. Just a digression after we've built the Docker container is what's the OCI thing that, well, we're saying sometimes OCI container, others OCI image, Docker container. What's really what we are talking about? Open OCI is Open Container Initiative. It's a Linux Foundation project, and it's specifications around containers. Container is a virtualization technology like virtual machines, and in different from virtual machines, they are a lot lighter. It's because they use the host operating system. Containers are really an illusion of the processes that run under the container, that they are using some kind of kernel facilities like namespaces or C groups. And there are different kinds of containers. You can have like LSC containers, or in this case, for example, OCI containers that are the one that we are going to talk about, because they have like immutable layers in the images, and then you have a when you start the container, you have like a new layer with copy and write semantics on that container, which make them very quick to start and very quick to stop. So basically, OCI is 3 specifications: runtime, image, and how they are distributed. And what I wanted to go is that you don't really need Docker to build or to run OCI images. You can use other tools like Docker, Podman, Builda, Scopio. And that's where we are going to go. We created an OCI image with Docker in previously, and now we are going to create it with Rockcraft. Rockcraft is another tool to create Docker images. And for that, well, we have to install the tool. If you use Ubuntu or other Linux distribution, you can easily install it as a snap. If not, well, I recommend you a little tool called PaaS, where you can have your virtual machines, kind of like Vagrant. But it's a bit nicer because you can use Cloud Init to customize your image. And with this, and with Rockcraft installed, you can just init with init profile Flask, and it will prepare a kind of Docker file, but it's a Rockcraft YAML file. And with that, you can pack your rock. That it's an OCI image. So let's see a bit how it works. We have our requirements with Flask, the application that we built before with just one very simple endpoint, and we can test it. As you can see, it's not recommended to run it that way, just for development. And we curl make a request to the application. As unexpected, it works. The Rockcraft version I'm using for this example is Rockcraft 1.5.3. One thing, you have the QR there, so if you go to that page, you will follow basically the same tutorial that I'm doing now. I create the Rockcraft file. You can see it's just that. It's very simple, quite commented in case you want to do a bit more complex things. The main difference between Docker and the Rockcraft is that Rockcraft is declarative. And we can just pack the image. It will take a bit of time. I've just fast forwarded it. And well, now that we have the rock image, that's basically an OCI image, just to prove that everything works perfectly, I'm going to run it with a Docker. So I will use the Scopio tool to copy the OCI image created with rock and deploy it to my local Docker instance. You can see that the image is there, and Docker can see it. And if we run it as expected, we can curl it, and it will work. And well, we've created two OCI images. The first one with Docker, the second one with Rockcraft. Both of them will work with these examples, but I'm going to use the one that I created with Rockcraft. So now I'm going to create a Helm chart. I'm going to run locally the microcades Kubernetes distribution. You can use other ones. Microcades is really nice for development, and we also use it in production in HA mode. Anyway, all the tools that I'm showing you related to this are open source, and you can use them at your home freely. So we create a namespace. We enable ingress because we will use it. Now Kubernetes is tending more over IP gateway, but that's another thing. We need to take the OCI image and deploy it to the microcades, the Kubernetes registry that we'll be using. And the next part is just creating the Helm chart. Helm chart has a file that defines the main information from the chart. You can see there that it's the name, type of application, and version of both of the chart and of the application. You can have the values YAML file that will define all the values that will kind of be injected into the Kubernetes manifest. It's a kind of a templated language, in this case, Go, as Kubernetes well is very Go. And you can take these values and kind of template the Kubernetes manifest. So the first one is the deployment manifest. As you can see, it has the name, the label, the spec for the replica set with everything, the replica count that we take for the values, or the values for the charts. And you can see the spec of the containers that will take the image from the microcades registry. Besides the deployment, we will also use a service manifest. Service as a kind of endpoint to load balance to the pods that are in the deployment. And as you can see, the target port of the just to point to the pod will be the pods will be 8,000, and the port exposed by the service is 80. The thing about the service and in Kubernetes is that it's not exposed outside the cluster. Well, that's half true, half false, depending on your CNI. But the proper way of being able to access to the cluster is to use something like an ingress. That's what we will do here. And we will simply create an ingress manifest that will make host page route to the Kubernetes service. And now that we have all the pieces of the puzzle, we have the chart in place. It's just installing it. It will be directly deployed to, in this case, to our Kubernetes cluster. And at that moment, well, not now, but 3 days ago, when I was preparing the presentation, it deployed everything to the cluster, and you can see that everything works perfectly, and you can curl make an HTTP request to the application. This Helm chart that we have created could go now to a repository of Helm packages and then being installed by other people. It's nice. You will use the full power of Kubernetes. However, as a main drawback, you will be very exposed to Kubernetes, and you will need to know how it works, and it will be a bit more complex for things like TLS termination, and you will have to prepare everything yourself. So we've deployed we've first deployed with a Helm chart, and now we are going to go to a platform as a service called Fly.io. It's a very simple one. It's really nice to do simple things, but we first have to install their client. I think their client is open source, but their infrastructure is proprietary. The nice thing about Fly.io is that you will run it in the servers. You will have first to register and put your credit card, name, and an email, and everything. And then when you run Fly launch, well, in not much time, you will see that it gives you information about how to deploy, information to deploy your application. We can check it. It has created just 2 files. One that specifies the characteristics of the machine. It's very interesting because it has created this file and one Docker file, but Docker file is not intended to be as a container, and they take the container and transform it into a virtual machine. Interesting that this is very similar to the first Docker file that we saw, and it also has the same problems. It's copying everything to the container virtual machine, and it's also running Flask in developer mode, something that we do not want for our production system. And well, after that, doing fly deploy, and it will take a long. I've just fast forwarded again. And very easily again, we can curl our system and it will work. Fly.io also prepared some URL with HTTPS. So summarizing is probably the simplest way of doing it. You can see the things. However, it has the same drawbacks of when we created the Docker file. It was, we could say that, not really production ready. And we are using the infrastructure of the PaaS. And the third option that I'm going to propose you is the one that we've developed in Canonical. You can take a picture of the QR if you want and follow the tutorial just to do it in your machine. That as before you can run it in most of the Linux distributions. If not, you can create a very simple machine as I said before with multipass. And Juju is a easy way to create a production grade deployment, and it's also easy to operate. And as I said before, we will run this locally also in the microcades cluster. And Juju is really an open source orchestration for software operators. So they will be like operators for every application. For the Flask one, if we have a Postgres one, and RabbitMQ or whatever operation, and they will communicate together. So in this case, we have to install the Chunkcraft tool, that it's the one that's to create the software operators. We'll prepare the Chunkcraft YAML that will find the characteristics of the operator, and then we will deploy. We'll create a model just to have of the applications together. We'll deploy the cham that will operate Flask and the Flask application. We will do it locally, but we will also deploy a Postgres instance, and that will be one cham already created. And then we will integrate it, and let's see a real example. Well, we are going to change the application a bit. In this case, we are also going to include Postgres. And for that, we have to change the requirements to include the Postgres client. The application will be a bit different. Let's see first that we will use environment variables, where we will get the Postgres database connection string that will have user, password, URLs, and everything, very in a 12-factor methodology way. And besides that, the charm will expose more environment variables for us. And if we connect to any other kind of application deployed with chams, kind of RabbitMQ, S3, all of them will be exposed as environment variables. There will be 2 endpoints, and now in the root one, besides replying a message, it will also insert one row in a table, and for visitors, we can check the visitors in that that have in the application. Clearly, this is not very production grade. There is no, but anyway. Another thing, we will need a migration, so we can create the visitors table. It will not appear by itself. It will also use environment variables, and it will be a simple function to create a table. You can also use Alembic, or in case you use Django, of course, Django migrations. This will be run automatically by the CHAM when you install it or when you upgrade it. We will update now the Docker image just to change the version. And I'm going to expand it, the CHAM. This is not exactly what you will run in any case, but you can see the declarative approach, and let's say it will just choose certain files. And you can also see that it runs Unicorn instead of just the development server. We will pack it again, and of course put it in the microcades registry, otherwise we will not be able to run it. And once we have the image ready in the container, the next part is to create the operator that will handle the software. Again, we'll use the tool Chunkraf, who will create a template for us that will have like information that will kind of configure the operator, and you will also have the source code. Most of these tools are written with Python. In this case, in the file, in the YAML file that configures the CHAM, what we will say is that we want to use a Postgres database. There are more options like MySQL, Postgres, MongoDB, Redis, S3. Besides that, and even if they are not shown by default, you have like ingress integrations, or let's say you can integrate with Grafana Stack, and you can deploy it also like in a similar way. We prepare the operator software. And once we have it, now we are going to deploy our third option. So we'll create the model to group the applications, and we will deploy them one by one, and they will be deployed to that model that it's in the case of Kubernetes, it's in a namespace, named as the same as the model. So one by one, Google will deploy all of them. It's very interesting because, well, we have really now deployed a full Postgres database that we can like put in HA mode and just sending messages with the same utility. You can say just like I want 3 instances of Postgres, and it will automatically go into HA mode with Patroni. And once all the applications are integrated, it will take a bit of time because it will have to deploy everything. But at some point, we will see that, again, we can make requests to our application. First, we have no visitors, then we have 1, then we have 2, and hopefully we will have millions, but I didn't have the time for that. So a bit of a conclusion. We've created an OCA image. We've done it in 2 ways. We've seen that, well, it works. Docker is really a very nice tool, but the first searches that Google gave us were not really ready for a production grade. We will then create the image with Rockcraft, and then we've deployed Helm chart. It exposes all the power of Kubernetes, but you also have to do all the manual writing, and you have to have all the knowledge for that. The second option is Fly.io. That's a proprietary platform as a service. It's probably the simplest of them. If you are going to deploy a very, very simple application, probably it's the way to go. but you will also have to work with the Docker file as it was not production ready. And the third option is deploying it with juju. Juju is open source tooling, so you can use it at home or in your company. It's production ready and provides integrations with other complex applications in a very easy way. Well, thank you very much. We will love to have your input about this tooling, and we'll really appreciate if you contact us if you have interested in that. You have there my contact email, and you can contact us on Matrix. Besides that, you have 2 tutorials, one for the OCI image with rock graph, and the other one that it's very similar to the one we did. There are also tutorials for Django, FastAPI, and other tools. Thank you very much.